Hello students, let us start with second lesson of class 10 mathematics Ncert. Okay, polynomials. You have studied polynomials in 9th standard. Okay, so we will not go in more detail. Okay, in depth, but you have also studied zeros of the polynomial and so on. So based on that and in continuation, let us see what do you mean by polynomials. Polynomials of degree 1, 2 and 3 are called linear, quadratic and cubic polynomials. If the degree is 4, then what it will be called? It will be called biquadratic. Okay, examples are given. The degree of the polynomial. So here the variable is x. So 2x plus 5. So here the degree, the highest power of the x in the expression or in the polynomial is called the degree of. Here nothing is there, means 1. So degree is 1, so it is called linear. Here highest, here x is there, here x square, here x, so power is 2, degree is 2. So it is called quadratic. Here x, here also x and here also x. The highest power of the x is 3. So it is called cubic polynomial. So the polynomials of degree 1, 2 and 3 are called linear, quadratic, cubic. If degree is 4, then it is called biquadratic. Okay, and so on. Okay. Let us see. Now what do you mean by zeros? Okay, the zeros of a polynomial. Okay, so the zeros of a polynomial p of x, polynomial is denoted by, last year you have studied in 9th standard, denoted by p of x are precisely the x coordinates of the points. X coordinates, listen carefully, x coordinates of the points where the graph of y is equal to p of x intersects the x-axis. Okay, this graphical method was not there or we have not seen in 9th standard. Here graphically how to find the zeros. 9th standard we have seen how to calculate zeros by substituting the value of check whether 2 is a zero of the given polynomial or not. Then in given polynomial is in x, you put x is equal, wherever x is there you substitute x by 2 or half, whatever the value. Okay, and it turns out to be 0, then you can say that is the zero of the polynomial. The value of the entire polynomial becomes 0. Then you say 2 is a zero of that polynomial. Here we are not going to see that way. Graphically we are going to see the zeros. Once again, the zeros of a polynomial p of x are precisely the x coordinates of the points where the graph of y is equal to p of x intersects the x-axis. Okay, based on this, there is exercise 2.1 in the textbook. I have randomly taken 4 examples. Okay, the graphs are shown. Graphs of y is equal to p of x are given in these 4 examples, and you have to find out the how many zeros are there in each case. There may be 0, there may not be zeros also. Okay, okay. Let us see. Now this is first one. So this is the graph. This is x-axis. This is y-axis. So this is the graph. So this graph y is equal to p of x is parallel to x-axis. It is not intersecting x-axis anywhere. So this polynomial has no zeros. Okay, it has no zeros. Okay, let us see second one. Here the y is equal to p of x. It is intersecting x-axis as per our definition, the zeros of polynomials. Okay, where it intersects the x-axis. So this y is equal to p of x intersect x-axis at 2 different points. One is here and one is here. So how many zeros? There will be 2 zeros for this p of x or this polynomial, you can say. Let us see one more example. Here the graph is this way, it is intersecting x-axis and it is also intersecting y-axis. Okay, if you notice then, but find out it is intersecting y-axis and it is also intersecting x-axis. Find out at how many places it is intersecting x-axis. If you notice, it is intersecting x-axis here only. We are not interested whether the graph is intersecting y-axis or not. Okay, that is not our lookout. Only we have to focus where it is intersecting x-axis. So it is intersecting x-axis in this point. So how many zeros? 1 0. So this will be having, this polynomial will be having 1 0. Let us see one more example. See the graph. Okay, so it is intersecting x-axis as well as y-axis. Y-axis how many points? Only 1 point. But we are not interested. in how many points it is intersecting y axis. Only focus where it is intersecting x axis. So just see, it is intersecting x axis here 1, here 2, here 3 and here 4. So you can say how many zeros it is having? It is having 4 zeros. So let us revise once again. No zero for this example, 2 zeros for this example, 1 zero for this example and 4 zeros for this example. Okay, so let us come back to this points. Okay, we have seen linear, quadratic, cubic. So linear will be having how many zeros? It is said linear x raised to 1, highest degree of variable is x is 1. So it will be having only 1 zero. Let us see now the relationship between the zeros and coefficients of the polynomial. We will discuss here two polynomials, linear polynomial and quadratic polynomial. What is linear polynomial? Of this type, ax plus b, where a is not equal to 0. Now you want to find the 0 of this polynomial. So how we will calculate? I have written here 0 of a of ax plus b is x is equal to minus b upon a. How this came? So you have to equate ax plus b is equal to 0. So x is equal to minus b upon a. So this is 0 of the linear polynomial. Same way, we will see now relationship. So this is what relationship between the zeros and coefficients of the polynomials. So ax plus b, a is a coefficient of x and b is a constant term. So x is a 0. And how? What is the relation? X can be expressed as minus b upon a. Okay. Same way we will explain for quadratic polynomial, ax square plus bx plus c, where a cannot be 0. Let us, now there is a theory part, I have written here the theory part directly. Okay, how this came, that we will not see here. Let us see. Let alpha and beta be the two zeros of the above quadratic polynomial. Then sum of the zeros. Now, before that, ax square plus bx plus c. What is a? A is a coefficient of x square. What is b? B is a coefficient of x. And what is c? C is a constant term. Now, let us develop the relationship. It is already given in the textbook. I have just written. We will see here. Relationship between the zeros and coefficients of the polynomial. Now this is quadratic polynomial. So how many maximum zeros it will have? It will have only 2 zeros. When we say about linear, it will be having only 1 zero. Quadratic, it will be having 2 zeros. Cubic, I have not written here. Cubic will be having 3 zeros. Biquadratic will be having 4 zeros. Let us see. Now this is quadratic polynomial. Sum of the zeros. So we have considered alpha and beta are the two zeros. So alpha plus beta. So what is the relation? Alpha plus beta is equal to minus b upon a. What is b? B is the coefficient of x. And what is a? Coefficient of x square. So that is minus b upon a. This is derived one. Derivation we are not going to discuss here. Okay. Now minus coefficient of x upon coefficient of x square. So you have to remember alpha plus beta is equal to minus b upon a. That is coefficient minus coefficient of x upon coefficient of x square. Let us see product of the zeros. Okay, that is alpha into beta. So what is the relation? Alpha into beta can be expressed as c upon a. What is c? C is a constant term. So constant term upon coefficient of x square. So this is relationship between the zeros and coefficients of the polynomials. Let us see now exercise based on this theory. Okay. Let us see now exercise 2.1. What we have seen the theory, the relationship between the zeros and the coefficients of the polynomial. So question first, find the zeros of the following quadratic polynomial and verify the relationship between the zeros and the coefficients. We have seen the theory. Let us see. First one, x square minus x minus 8. You want to find the zeros, means you have to first find the factors. How to factorize this? By splitting the middle term. So we have done this way, x square minus 4x plus 2x minus 8, and we are arrived here. The factors of this are x minus 4 into x plus 2. equate this with, we want to find 0. So equate this with 0. So x minus 4 is equal to 0. Therefore x is equal to 4. Same way x plus 2 is equal to 0. Therefore x is equal to minus 2. So the required zeros are 4 and minus 2. Now we want to find the relationship, verify the relationship. Okay, let us see sum of the zeros. Sum of the zeros, 4 plus minus 2 is 2. And what is our theory? Alpha plus beta is minus b upon a. What is minus b? Minus b is minus 1 here. Okay, minus b is coefficient of x and that is minus 1. And what is a? Coefficient of x square, that is a, and that is 1 here. So 2. So what it is? 4, sum of the zeros, 4 plus minus 2 is 2. So minus coefficient of x. So minus sign is there, and what is coefficient of x? That is minus. So minus into minus 1, that is plus 1. So here we got 2. And what is coefficient of x square? 1. So 2 upon 1 is 2. So this is a verification. Same way, product of the zeros. What is product of the zero? Multiply this. 4 into minus 2 is minus 8. But as per theory, what is the product? Product of the zeros is c upon a. What is c? C is a constant term. So what is constant term here in this quadratic equation? Quadratic polynomial? Minus 8. So we got here minus 8. Constant term is minus 8 upon coefficient of x square. What is coefficient of x square? 1. Okay. So minus 8 upon 1, and that is minus 8. So this is verification we have done. You can practice similar sums. Let us see second question. Find the quadratic polynomial each with the given numbers as the sum and product of its zeros respectively. So first one is 1 upon 4. So what is 1 by 4? Is a sum. So what are the zeros? Later we have to assume that alpha and beta are the zeros as per theory. So alpha plus beta, the sum is 1 by 4 and the product is alpha plus into beta is minus 1. So this is a required standard form. Required quadratic polynomial is given by x square minus alpha plus beta into x plus alpha beta. Just substitute the values. Okay, let us see. So x square minus, what is alpha plus beta? 1 by 4. So 1 by 4 into x plus, what is alpha beta? Alpha plus beta is minus 1. Okay, so what you will have? So it is nothing but x square minus x by 4 plus into minus 1. So this way, or you can multiply, you want to remove this 4. So multiply all the terms by 4. So we will get 4x square minus 4 into x by 4 minus 4 into 1. So this is nothing but 4x square minus x minus 4. So this is our required polynomial when the sum of the zeros is given and the product is given. Okay. Let us see some more examples of this type. Another one, when sum of the zeros is root 2 and product is 1 by 3. So here alpha plus beta is root 2 and alpha beta, that is alpha into beta, is 1 upon 3. So required quadratic polynomial is given by x square minus alpha plus beta into x plus alpha beta. Just substitute the values here. Okay, so is equal to x square minus, what is alpha plus beta? Root 2. So root 2 multiplied by x plus, what is alpha beta? 1 upon 3. Okay, so this is the required quadratic polynomial. You can further simplify. We don't want 3 in the denominator, so multiply every term by 3. So what you will get? So 3x square minus 3 into root 2x plus 3 into 1 upon 3. So 3x square minus 3 root 2x plus 1. This is the simplified form. Okay. Let us see one more example based on this type. Let us see. Fifth one is minus 1 by 4 and 1 by 4. So here alpha plus beta is minus 1 by 4 and alpha into beta is 1 by 4. So required polynomial. So required quadratic polynomial is given by x square minus alpha plus beta into x plus alpha beta. So just put the values. X square minus, what is alpha plus beta? Minus. So minus 1 by 4 into x. What is alpha into beta? 1 upon 4. So x square minus into minus, so plus. So 1 by 4 into x plus 1 by 4. We don't want this 4 in the denominator, so multiply every term by 4. So you will get here 4x square. When I multiply 4, 4 get cancelled, so what remains? X. 4, 4 cancels 1. So this is a required quadratic polynomial when the sum of the zeros is minus 1 by 4 and the product is 1 by 4. Let us see another discussion, another point, division algorithm for polynomials. What is that? If px and gx, that is p of x and g of x, are any two polynomials with g of x not equal to 0, then we can find the polynomials q of x and r of x such that p of x is equal to g of x into q of x plus r of x. If you recall from the lower classes, it is nothing but what you studied, a simple division. Dividend is equal to divisor into quotient plus remainder. So here q for quotient and r for remainder you can remember this way. Based on this is called division algorithm for polynomials. Based on this, there is exercise 2.3, question number 1 and 2. Let us see. First question I have taken here. Divide the polynomial p of x by the polynomial g of x and find the quotient and remainder in each of the following. I have taken first one. P of x is given x cube minus 3x square plus 5x minus 3. If you notice here, okay, the degree of this polynomial is 3 and then there is no term missing in this. 3, 2, 1 and here x raised to 0. So constant. Divisor g of x, x square minus 2. X square, then x term is missing. So I have supplied, I will rewritten here this way. X square minus 2 can be x square plus 0x minus 2. Okay, let us divide x cube. Now I want to eliminate x cube. So I am having here x square. Concentrate on this. So multiply by x. Okay, so x into x square is x cube. X into this, that is 0x square. X into minus 2. So minus 2x. Now subtract this. Change the sign. Plus, minus and minus. So plus x cube minus x cube is 0. Minus this is 0. Whether we are changing sign, it doesn't make any difference. You have to concentrate on this only. So it is minus 3x square. Now plus 5 and plus 2. It is 7x. Bring down one more term. Okay. Let us see. Now we want to eliminate minus 3x square. So here we are having x square. So multiply by here, right here minus 3. So minus 3 into x, that is minus 3x square. Minus 3 into this 0x, that is plus minus into this. So it is minus 0x. It doesn't make any difference. And minus into minus is plus 6. Okay. Minus plus plus minus 3x square plus 3x square is nothing but 0. Okay, plus 7x plus 0x, so that is plus 7x minus 3 minus 6, so minus 9. Okay, so what is quotient? We have to find quotient and the remainder. So we write here quotient is x minus 3, and what is remainder? Remainder is 7x minus 9. Before going to solving question number 2 of 2.3, I will say in question number 1 there are 3 sub questions. One I have solved, remaining 2 you have to practice, and some others from other material you find out and try to solve it. Okay, let us see question number 2. Check whether the first polynomial is a factor of the second polynomial by dividing the second polynomial by the first polynomial. Okay, so first polynomial is x square plus 3x plus 1, and the second polynomial is 3x raised to 4 plus 5x cube minus 7x square plus 2x plus 2. So you have to check whether this polynomial, first one, is a factor of the second polynomial. So what is the meaning? When it is a factor, what is the meaning? A remainder should be 0. If remainder comes 0, then you can say this is a factor of this, or first polynomial is a factor of second polynomial. Let us solve this. Okay, so x square plus 3x plus 1, and here 3x raised to 4 plus 5x cube minus 7x square plus 2x plus 2. Okay, try to divide this. Okay, we want to eliminate 3x raised to 4. What we are having here, x square. So we have to multiply here 3x square. So 3x square into x square is nothing but 3x raised to 4. 3x square into 3x. 3 3s are 9x cube. 3 into 1. So that is 3x square. Now subtract this. Minus, minus, minus. So plus 3x square minus 3, plus 3x raised to 4 minus 3x raised to 4 is 0. Okay, plus 5 and minus 9x cube. So it is nothing but minus 4x cube, and minus 7 and minus 3x square is nothing but minus 3 minus 10x square. Bring down one more term, that is 2x. Okay, now we want to eliminate minus 4x cube. We are having here first term as x square. So minus 4x. So minus 4x into x square is minus 4x cube. Minus 4x into plus 3, that is minus 12x square. And minus 4x into 1, that is minus 4x. Subtract, plus, plus, plus. So this term is 0. Minus 10 plus 12x square. So that is 2x square plus 2 plus 4, that is plus 6x. Bring down this 2. Okay, we want to eliminate 2x square. So we are having x square, so plus. So here plus 2x square. 2 into 3, that is 6x. 2 into 1, that is 2. Change, subtract. When you are subtracting, you are changing the sign. So everything is here 0. Plus 0, plus 0, everything is 0, 0, 0. So what here? Remainder is 0. So what you can say? You can say first polynomial, that is x square plus 3x plus 1, is a factor of 3x raised to 4 plus 5x cube minus 7x square plus 2x plus 2. Why? Because remainder is 0. If remainder does not turns out to be 0, then it is not a factor. Hello students, today we will see exercise 2.3, third question. before that, I would say question number 4 and 5 you will try yourself. Okay. Third, let us see. I will return the question. Obtain all the zeros of 3x raised to 4 plus 6x cube minus 2x square plus minus 10x minus 5 if two of its zeros are root 5 by 3 and minus root 5 by 3. So let Px is the given polynomial. Given that these two are root 5 by 3 and minus root 5 by 3 are the two zeros of the given Px. So what is the meaning? They are the zeros. So this is positive. So x minus root 5 by 3, this is negative. So x minus into minus. So this will become positive. So sorry, x minus root 5 by 3 into x plus root 5 by 3. If you simplify, we are getting x square minus 5 by 3. Now we want to eliminate this 3. So multiplying all the terms by 3. So we will get 3x square minus 5. What is the meaning? So these two are the zeros, means 3x square minus 5 is a factor of p of x. Okay. So we have to divide now the given polynomial by this factor. So 3x square minus 5. So what is the missing? X term is missing. So I have supplied here missing term 3x square plus 0x minus 5. Let us divide this. Okay. So I will eliminate 3x raised to 4. So I am having 3x square. So I will write here x square. So this will be 3x raised to 4, x square into this. So 0x cube, x square into this, minus 5x square. Subtract now. So till the side minus will become plus, plus will become minus. So this becomes 0. This plus, so this cancels out. So this is 0 plus 6 and this is 0. So 6x cube minus 2 plus 5. So plus 3x square minus 10x. Okay. Now I want to eliminate x cube. I am having 3x square. So I will multiply by 2x. 2x into 3x square. So it is 6x cube. 2x into this. So 0x square. 2x into this minus 5, that is minus 10x. So change the sign. So 0 plus 3x square plus 0 minus 5. Okay, I want to eliminate this. So 3x square, already 3x square is there. So plus 1. 1 into 3x square is 3x square. 1 into 0x. So that is 0, okay, and minus 5. So finally plus, so this is all turns out to be 0. So remainder is 0. So now what to do? We have to factorize x square plus 2x plus 1. The quotient, why you want to factorize? To get the 2 more zeros. The question is find the, obtain all the zeros. Now how many zeros this polynomial will be having? The highest power is 4, degree is 4, so it will be having 4 zeros. Out of 4, 2 are given to us. So you have to find a remaining 2. Okay, let us see further. Now Px is equal to Gx into Qx plus R of x. This is division algorithm for polynomial. So what is Gx? So Px we know very well. What is Gx? Gx means divisor. Our divisor is 3x square minus 5 multiplied by, what is our quotient? Quotient is x square plus 2x plus 1 and remainder is 0. So we will factorize this. Okay. So let us see here. So is equal to 3x square minus 5 into x square plus 2x plus 1. So you know the factor x square plus 2x plus 1 is expansion of x plus 1. So 3x square minus 5 into x plus 1 into x plus 1. So now this is already factor is given. Now another factors. Now plus 1 is equal to 0, and again x plus 1 is 0. So therefore x is equal to minus 1, x is equal to minus 1. So therefore required all zeros are, okay, so root 5 by 3 comma minus 5 by 3, this is given to you, and you have calculated minus 1 minus 1. So 4 zeros. So it is a polynomial in degree 4. So 1, 2, 2 are given, 2 more we have calculated. Okay. Hello students, let us see one more solve similar to question number 3 from 2.3. I have selected this from optional exercise 2.4, question number 4. I have not written here the number. The question is, if two zeros of the polynomial x raised to 4 minus 6x cube minus 26x square plus 138x minus 35 are 2 plus or minus root 3, find the other zeros. Let Px is the given polynomial. Given that 2 plus root 3 and 2 minus root 3 are the zeros of the given polynomial. So x minus this and x minus this, okay, will be the factor of this. So we have to simplify it as x minus 2 minus root 3, x minus 2 plus root 3. Arrange it. So x minus, we are getting x minus 2, x minus 2, minus root 3 plus root 3. So we will write in the form a square minus b square. So here what we are getting? X minus 2 whole square minus root 3 whole square. So it is x square minus 4x plus 4 minus 3. And we are getting x square minus 4x plus 1 is the factor of p of x. So now divide the given polynomial by this to get other zeros. So here is the simplification. You can see carefully, okay, as we have studied in 2.2 and all. This is nothing but division algorithm and how to divide. Okay, so finally we are getting p of x is equal to g of x into q of x plus r of x. This is division algorithm. What is g of x? Divisor. X square minus 4x plus 1. What is q of x? X square minus 2x minus 35. And what is remainder? 0. So this can be written as x square minus 4x plus 1 into x square minus 2x minus 35. How we got this? We have seen in the beginning by simplifying. Okay, so you have to factorize this to get your two more zeros. Okay, so this is nothing but x square minus 4x plus 1 into x minus 7 into x plus 5. So x minus 7 is equal to 0 and x plus 5 is equal to 0. So therefore x is equal to 7 and x is equal to minus 1. So therefore required all the zeros are, okay, two zeros are given to you. So 2 plus root 3 into 2 minus root 3, we have calculated 2 more. So 7 and minus 5. So these are the 2 more zeros. Okay.